that integral f comma g is equal to -1 to +1 f of x into g of x dx. Basically, it is the same as f star of x, but since it is a real valued function, f star of x is same as f of x. So this is my inner product. Now, consider a monomial basis. Yesterday we have talked about this monomial basis. What is a monomial basis? Monomial basis is 1x squared. That means I will define m0 of x as 1, m1 of x as x, m2 of x as x squared, and so on, mn of x as x power n. This is the monomial basis. I will call mn of x as monomial. Now note that this monomial basis is not orthogonal with respect to this inner product space. Because if you take x and x cube, that's not 0. So it's a non-orthogonal basis. It's a basis, but it is a non-orthogonal basis. This is a linearly independent set of polynomials or monomials, but they are not orthogonal with respect to this inner product. I said orthogonality has to be taught only with respect to your defined inner product. So I define the inner product. With respect to this inner product, they are not orthogonal. So now the proposal is that shall we use Gram-Schmidt orthogonal procedure that we have already discussed to orthogonalize these vectors? Is it a good question to ask? So let us do that exercise. So let me write, so using Gram-Schmidt procedure, we can construct orthogonal basis. From monomial basis, we can construct an orthogonal basis. So how do we do that? Let me call the first such element P0 of x as same as M0 of x. That is how we started, right? First element is same as the first element of that. That is basically 1. Now P1 of x, the second element should be M1 of x minus inner product of M1 with P0 divided by P0 into P0. I have to evaluate two inner products here. Remember. So what is the inner product? So let me evaluate these two inner products. P0 M1. What is that? That is equal to integral -1 to +1 P0 of x into M1 of x dx. What is this equal to? -1 to 1. P0 of x is 1. M1 of x is x dx. So this will be 0. Because this is x square by 2 from -1 to +1 is 0. And this is never 0 because P0 is the norm of that. That is never 0. So this entire thing is 0. So I will have This is x. Okay. Now you can also ask a question that P0, P1 is 1. Now let's call P2. I want to talk about P2 of x. P2 of x is M2 of x minus P0 M2 divided by P0 P0. P0 M2 divided by P0 P0. And okay, so before that, let me also say that this is my P1, right? But I can also normalize P1. How do I normalize P1? I ask what is P1 P1. P1 P1 is nothing but P1 is x. So it is minus 1 to 1 x square dx. That is equal to 2 by 3. So I want P1 P1 to be equal to 1. Then I must multiply P1 with root 3 by 2. So I will say root 3 by 2 into x. If I write, it is normalized. Not only orthogonal, I want to get orthonormal, let us say. Okay. I want to get orthonormal, then this is, but let me, at this moment, let me not worry about normalization, let me put it as x. Let us say about normalization later. So this into P0 of x minus P1 M2 by P1 P1 into P1 of x. Correct? Okay. Now you can ask what is this P0 M2? P0 M2 is equal to integral minus infinity to minus 1 to plus 1. P0 is 1, M2 is x square dx. This will give you 2 by 3. And P0 is how much is P0 P0? Is equal to minus 1 to 1 dx, which is equal to 2. And P1 M2. P1 M2 is equal to integral minus 1 to 1. P1 is x, M2 is x square dx. This is x cubed. So any odd power of x will be 0. Okay? Because it's an odd function and this interval is symmetric, odd power of x is 0. So this is 0. So this will not contribute anything. Whereas this one contributes 2 by 3 divided by 2. So this is 1 by 3. Into P0 is 1. So I have P2 of x is equal to x square minus 1 by 3. X square minus 1 by 3. Okay. Now I will go on constructing further this. Correct? Okay, now you can ask normalize. If you normalize, since I know P0 is equal to 2, normalize to P0, which I will call it as P0 tilde is equal to 1 by root. So that P0 tilde normalized is equal to 1. Similarly, Now if I use normalized thing here, this becomes 1. This anyway is 0, so I have no problem. Now I have P1, as we have seen, is equal to 2 by 3. So P1 tilde is equal to square root of 3 by 2 into x. Correct? Square root of 3 by 2 into x. So that P1 tilde is also equal to 1. Now here, this does not contribute anything, but this contributes. If I use instead of P0, I use P0 tilde. What happens? This is 1. So imagine I am using P0 tilde here. This is 1. And what is this equal to? P0 tilde M2 is equal to 1 by root 2 into integral minus 1 to plus 1 x square dx. That is equal to 2 by 3 root 2. Correct? 2 by 3 root 2. So I will have 2 by 3 root 2. And what is P0? Is another 1 by root 2. So I will have 2 by 3 root 2 into this is 1. I have 1 by root 2. So this is anyway cancels with this root 2 root 2. I will have x square minus 1 by 3. But now I also now require P2 to be equal to 1. So I ask, what is P2 of x? P2 comma P2. That is equal to. So what is this equal to? This is x cubed minus 1 by 3. Sorry, x square minus 1 by 3. So if I write integral minus 1 to 1, x square minus 1 by 3, the whole square dx. Okay, that is what is this. So this is equal to minus 1 to 1 x to the power 4 minus 2 by 3 x square plus 1 by 9 dx. So this will not give you anything, this will not give you anything, but this will give you 2 by 9. Correct? So this is equal to 2 by 9. So which implies into tilde.
So the first and second will complement.
Yeah, even will not contribute because I will get x power 5. Oh, even will not. Yeah, you are right. So this will be equal to x power 5 by 5. So 2 by 5 minus 2 by 3 into 2 by 3 plus 2 by 9. So this is minus 4 by 9. So minus 4 by 9 plus 2 by 9 is minus 2 by 9. So I will have 2 by 5 minus 2 by 9, which is equal to 45, 18 minus 10. So that is equal to 8 by 5. So P2 will be equal to square root of, okay, so I will write 45 as 9 into 5 and 8 as 4 into 2. So that is equal to 3 by 2 into square root of 5 by 2 is into x square, sorry, yeah. So you may not write this here. 3 by 2 into square root of 5 by 2 x square minus 1. So normalized values if I write up to P0, P1 that I have calculated, T0 tilde of x is equal to 1 by root 2, T1 tilde of x is equal to root 3 by 2 into x, and T2 tilde of x is equal to root 5 by 2 into 3x square minus 1 by 2. 3x square minus 1 by 2. And if you